Okay, the first part of the question is classic completing the square. Express x squared plus 6x in the form x minus a squared minus b. If you've seen the Mission A Star quadratic millionaire video, you'll know what to do with this. The minus 6 is the thing you're going to have to start with. You halve that to get... Oh, I'm on the line tool, sorry. Can I erase this? Yeah, whatever. Yeah, right. I'm just getting used to this stuff. Anyway, sorry. X squared minus 6x. So you halve the minus 6 and you get minus 3, and you put that in a square bracket, and you've got x minus 3 squared. Now, what to do next? Some people get confused at. Think about what x minus 3 squared is. It's x squared minus 3x again minus 6x plus 9. You can work that out the long way if you want to, but if you can't trust me on that, it's correct. So x minus 3 squared is x squared minus 6x plus 9. So the question is, what do we do to x minus 3 squared to get just x squared minus 6x? Well, it should be reasonably obvious to you that to get from x squared minus 6x plus 9 to x squared minus 6x, we just take 9 away. Therefore, x minus 3 squared minus 9 is just x squared minus 6x. And now we've done the first part of the question. We've rearranged it in the complete square form, and so we can say x squared minus 6x is the same as x minus 3 squared minus 9. That's our answer. Which means that a is 3 and b is 9. It then says sketch the graph. Now, why did we do this whole completing the square business? Well, this comes back to what we do to a function if we replace x with x minus 3, and if we then subtract 9. This completed square form tells us where the vertex of the quadratic graph will be, i.e. Where the minimum point is if it's a happy quadratic graph, or the maximum point if it's a sad quadratic graph. This is a happy one, we know because the coefficient of x squared is positive. And we have two different forms that we can use for the sketch. I know that's not perfectly vertical, but hey, I'm still messing with this, so we'll just leave that. Now, this is our... Let me go back to the writing tool. It won't let me write now. Yes, thank you. Right, so this is our complete square form. Sorry, I have to wait for me to write that out. And this is our non-completed square form. I'll think of a name for it quickly. Normal. Okay, let's call it the normal form. Now, these two ways of expressing x squared minus 6x both have their advantages when it comes to sketching a graph. In the normal form, if we're looking at y equals x squared minus 6x, there's one thing that... Oh, sorry. Well, actually, there's two things that come out of this. One is that if we... Where did that come from? Sorry. One is that if we plug in x is 0 and y is 0, we can work out where the axes intercepts are. So the normal form is good for working out the axes intercepts. What I mean by that is where this curve goes through the x and y axes. For the previous question, we know that for the y-axis, x is 0, and for the x-axis, y is 0. So if we make x equals 0, we can clearly see that y equals 0 squared minus 6 times 0, and so we know that y, well, I'll write that out just for the hell of it. Y equals 6 squared minus 0 squared minus 6 times 0. Why did I put a squared there? Which is 0. So when x is 0, y is 0, therefore it goes through the origin. And when y is 0, we know that x squared minus 6x equals 0. Now, to solve this, there's nothing complicated you have to do. If you see that x is a factor of both, you can just say that x times x minus 6 equals 0, and therefore x is 0, which we already knew, or x is 6. So the other x-axis intercept is over here at 6. I probably shouldn't mark it with an x, but hey. Incidentally, if you had something more complicated for y equals 0, if it was x squared minus 6x plus 1 equals 0, then you've got various techniques that you know for solving a quadratic, i.e. working out where the graph of the quadratic would go through the x-axis. So if it was x squared minus 6x plus 1 equals 0, you'd use the quadratic formula, and you'd work out from minus b plus minus b squared minus 4ac, the root of all over 2a, where it went through the x-axis. Here, though, it's easy just to solve this quadratic by factorizing. Now, back to the quadratic. We know it's a happy quadratic. It's going to look like a big smiley face. It goes through 0 and 6. And because quadratics are symmetrical, you know that the vertex is going to be halfway between them. So you could reasonably guess that it's going to dip somewhere here. It's going to look like that with the dip at 3. But the completed square formula gives you a bit more information. This bit here tells you where the minimum point is, because the value of x that makes this expression x minus 3 squared as small as possible, i.e. 0, because anything squared can never be negative. If we put x is 3 in here, then this is the smallest value it could possibly be. So we know that when x is 3, then x minus 3 squared minus 9 is at its lowest possible value. We also knew that by symmetry anyway, but there you go. So we know that the vertex is at 3. We also know that if we make x 3, then x minus 3 squared minus 9 is equal to 0 squared minus 9. And so this tells us that the vertex of the graph is here at minus 9 on the y-axis. And now we can sketch. If we join up those points, we've got the x and y-axis intercept the origin. We've got our vertex at 3 minus 9, which we worked out by completing the square. We've got the 6 on the x-axis, which we worked out from subbing in y equals 0 into the normal version. And that is the sketch. That seems like a lot of work. With practice, this type of question is very standard, and hopefully you should get to the point where you can do it a lot more quickly than I've just done it.